The next presenter is Sahana Srivathsa. She's a doctoral student in the neuroscience graduate interdisciplinary program, and the title of her presentation is Neural Communication in Aging and Memory.
Neural communication in aging brains. We all have that feeling when we're running late in a rush, but then we forget our keys. So you come back inside and try to find them, but then your mind goes blank. You forget. Was it my keys, my wallet, my phone? What was I looking for? It's so frustrating. But imagine if this starts happening more and more often, and it's not just your wallet or your keys, but you start forgetting your pets, where you live, or even family members. This is the reality for over 20% of adults who are 60 and over who suffer from memory loss. Long-term and working memory are the most commonly affected cognitive functions with age. And these are caused due to interactions of two regions of the brain, known as the prefrontal cortex and the hippocampus, which are in constant communication with each other. Our hypothesis is that disruptions to this communication is what leads to memory deficits. So, in order to study this, we first need to understand, how do neurons communicate? Well, let's take an example. Let's say we have two cyclists who want to have a conversation. As long as they're traveling at the same speed, they're able to hear everything the other has to say and effectively communicate. The same is true for brain regions. Two regions that want to communicate produce oscillations or brain waves that are of the same frequency. This then allows neurons to align to specific locations along these oscillations and send information. So, brain regions that might be far apart in the brain can communicate through oscillations by creating a common code. And interestingly, cognitive functions like memory tend to occur in very specific bands, like theta oscillations or 4 to 7 hertz. But what happens if one of the regions moves outside this narrow frequency band? Let's go back to our two cyclists. Now, one of them's a little tired and can't keep up. So, they might still be able to communicate when they cross each other or by shouting, but most of the conversation is lost. Similarly, if brain regions aren't oscillating at the same frequency, they are not able to effectively align the neurons and send information. So, what we find is that in aging, the prefrontal cortex has oscillations that slow down, but not the hippocampus. This means that there's not enough synchrony, and the goal of my project is trying to understand what information gets lost when there isn't synchrony between these two regions in aging. So to do this, we look at these two brain regions in rats and study them while they perform different memory tasks to understand the role that synchrony might play while performing memory tasks. I think it is imperative for us to understand how memory changes over healthy cognitive aging before we can look at more complex disorders like Alzheimer's or dementia. Thank you.